Okay, YouTube, this is my next video on using the addition method to solve systems of nonlinear equations. And what I want to do here is essentially look at a special instance where we get a one solution case that we can see over here graphically, but also look at how we can use addition method with something that is not already written in a form where addition method would work. And so the interesting thing is, because I want to use addition method on something like this, typically what we see is that both equations, would have to be in this form here. At least that's what I said in my last video. I said those words. I said them. But the thing here is that in this particular instance, what I want you to see is that if we were to take our first equation here and subtract, this y equals x squared plus 3 here, and if we were to subtract the x squared from both sides, we would end up with negative x squared plus y equals 3. And so to rewrite my original system, let me do this for you here. I'd say negative x squared plus, and I'm going to write this as, I'm going to put my y over here, equals 3. And because what I want to show you here is essentially this. The second equation is x squared plus y squared, which is not the same thing as a y to the first, equals 9. If we were to add both of these right now, just to essentially what we get is these x squareds cancel out, and what we get left with is just 1y squared plus a single y equaling 12. And so with something like this, what we want to indicate is basically we have one variable type. And so we could have done this with substitution. As a matter of fact, if we did this with substitution, we already had y by itself. It's just that we would have had to plug that back in and square an x squared plus 3, which makes it a little bit more complicated than what we could have done if we had just done addition method. So keep your eyes peeled for something like this, that even though the y's are not both of a squared type or of a first type, if you were to cancel out your x's squared, you're only left with one variable type, which is what we want there. And so let's go ahead and do this. Let's go ahead, because this is quadratic, let's go ahead and subtract 12 from both sides, or at least in generally speaking, so set this equal to 0 and try to factor this. And I think that this would factor, we say 2 factors of a negative 12, okay, that add up to be a positive 1, that have to be a 4 and a 3, and I would think that the 4 would have to be positive here and the 3 would have to be negative. So we say y plus 4, y minus 3. If that's the case, then certainly we'd say, well, then either y plus 4 had to equal 0 or y minus 3 has to equal 0. So solving each of these individually, of course, we get negative 4 for our y value here, and we get a positive 3 for our y value here. And we want to come over here and list our solutions. Now, the interesting thing is, at this point, had I not had a graph, had I not had this graph that shows me that there's only one solution, I would have written solutions. I'm still going to write solutions, okay? But what I want you to see here is this. If we were to plug these in and go backwards and solve for, I suppose, our x value, we're going to see some unique things happen. And so let's start with this. We say our solutions, of course, we would have been inclined to write this here. We would say that y, I'll put it in blue here, y equals 3, and y, well, let's put negative 4 first, since we kind of wrote the negative 4 first over here, and then I'm going to get a 3. When we plug this back in, thing is, it doesn't matter which equation we use, and so since I suppose that I'm solving for x, I don't know, let's go ahead and let's plug it back into this equation here. And so we would see that y equals x squared plus 3, where we're plugging in for y now, okay, x squared plus 3. We're plugging in a negative 4 for our y value. And so check this out. When we plug this in, essentially we would have to solve this using square roots. We'll subtract 3 from both sides. We would get x squared on the right equals a negative 7 on the left, and the natural next move here would be to take the square root of this. And so what we get is the square root of negative 7, which really is I times the square root of positive 7, but what we would say is that it's a non-real result. And the simple fact of the matter is that we're only interested in real results. And so that's why this one here doesn't work. And so we have to check these. We say when we check for 3 here, when we plug this back, and we're going to say y equals x squared plus 3, we're going to see that plugging in for y here, a 3, pretty easily gives us a value of 0 for x, because when we subtract 3 from both sides here, what we get is x squared on the right equaling 0 on the left. So x is equal to the square root of 0, which is 0 and 0. But what we get is essentially we get a 0 here. So there's only one solution to this, but algebraically we see that it has only one solution because the other one just doesn't work out algebraically when you plug it back in. Cheers.